All right, so here we are with 11 free volumes of pyramids and cones. Our objectives are to learn and apply the formula for the volume of a pyramid, and then also learn and apply the formula for the volume of a cone. So the idea between prisms and pyramids is that to find the volume of a pyramid, so the guy with the point here, you just need to find the volume of the prism that would have had that same base and divide it by 3. So if you take a look at this image, what they're trying to show you here is that this this rectangular pyramid would slide over to be this base here. This one would slide down to be that back side, and this one here would slide over to be this right side, and it would end up making that entire cube or rectangular prism. So the idea is that we're going to use the same formula. That volume is the area of the base times the height, but we're going to divide it by 3 when we're doing a pyramid. So just a new, just the same thing again, but divided by 3. So taking a look at our first example, we are going to find the volume of a rectangular pyramid. So again, a rectangle on the bottom coming to a point pyramid with the length of 7 feet, a width of 9 feet, and then a height of 12 feet. So we've got the base here, and then they're saying that the height would be 12. So the volume again is a third now of the area of the base times the height. And so that area of the base is going to be the length times the width. So we're going to do 7 times 9 eventually. And so we're going to get a third. And again, this is our length. This is our width. So a third times 7 times 9 times a height of 12. So 7 times 9 times 12. So we've got 252. I took 7 and 9 and 12 multiplied and divided by 3, and we're going to get 252. And since it is a volume, we're going to do feet, but then cubed. And that's our measurement. Again, if you multiply that by 3, then that would be the rectangular prism, but we're doing the pyramid. All right, next one we have an image, and they're saying that the height is 6. The base is 4 by 4, so this must be a square pyramid. It says it in the problem here. So again, the volume is just going to be a third area of the base times height. But of course, now our area of the base is side squared times height. So our side length is 4 and our height is 6. So if we plug that in, we get a third 4 squared times a height of 6. And so we're going to end up with 32. And the units are inches and then cubed. All right. So moving on to example 3. We are now going to find the volume of a trapezoidal pyramid. So again, that just means that it has a trapezoid as its base, and then all of the side lengths are triangles coming to this point at E. The base is ABCD, so that's this one here. A, B, and CD are parallel because otherwise it would not be a trapezoid. And then it says that AE is perpendicular to plane ABC. So AE is perpendicular to the base. Okay. So all it's saying is that it kind of has more of like this kind of a oblique leaning issue. So either way, we still know what the height is going to be. They're giving that with this 10 here because A to E is perpendicular, and so therefore it's the plane. Therefore it's the height. So 10 is our height. We are going to have to find the area of the trapezoid because our volume is a third area of the base times height. And the area of our base is going to come from the Trapezoid Theorem, which says it's a half of base 1 plus base 2 times height. All right, and then times the height of the pyramid. So again, this one's the height of the pyramid. I should probably spell pyramid right there. It is. And then this is the height of the trapezoid. So plugging in our pieces, we've got a third that we're multiplying by a half. Our first base is 18, second base is 9, so 18 plus 9. The height of this trapezoid is 6, and then the height of the pyramid itself is 10. So we're going to go ahead and multiply all of those pieces. Times, what's 18 plus 9? 27 times 6 times 10. All right. So we're going to get 270, and the units are meters cubed. All right. Going to the next one. So instead of a pyramid, now we're talking about a circle base. So we call it a cone. The volume of a cone is given by a third, again, of the previous area volume formula. So it used to be pi r squared height, but now it's a third pi r squared height. So when we had a cylinder, we're now talking about a third of that cylinder coming together. So if we're going to find the volume of the cone with a radius of 5, so that's our r, and our height of 12, we need to give our answers in both terms of pi and rounded to the nearest tenth. So when we set this up, we have a third pi r squared height. And so we're going to plug in an r of 5, as I mentioned up here. That'll be squared, and then a height of 12. So in order to get this in terms of pi, we need to evaluate what just the one piece is. So we're going to kind of skip the pi value and multiply all of these pieces. So we're going to multiply a third times 5 squared times 12, and we'll get 100. So that means that we have 100 pi as one of our answers, or if we actually took the chance to make that into its decimal, pi times 100 just moves that decimal place of pi over 2 places, so 314.16. It does say to the nearest tenth, so I guess we'll just say 0.2. And that's centimeters cubed. All right, our next example says that we're going to find the volume of a cone with a base circumference of 21 pi. So this is where they're having you work backwards to find the radius and then using that to find the volume. They say that the height of this cone is 3, so we'll want to mention that. And again, this is the circumference, not quite the radius yet. The height isn't actually 3. The height is 3 centimeters less than twice the radius. Okay. So the height is 3 centimeters less than twice the radius. So kind of a formula going on there. All right, so the first thing we're going to do is find our radius using circumference. So the circumference is said to be 21 pi, but in reality, circumference equals 2 pi r. So if we want to get our r value, which of course we do, we're going to need to divide both sides here by pi. Leave us with 21 equals 2r, and then divide both sides by 2 and get an r of 10.5. So now we know that our radius is 10.5, so we can put in a 10.5 here, multiply by 2, subtract 3, and we're going to get our height. So 2 times 10.5 is 21, minus 3 leaves you with a height of 18. So now we know that our radius is 10.5 and our height is 18, and so we can put them into our volume formula. So again, we're doing the volume of a cone, so it's a third pi r squared height. So we'll do a third times pi times 10.5 for the radius squared times height, which is 18. Remember that they do want you to do it in terms of pi and then the nearest tenth. So we go ahead and evaluate just the one piece. So we're going to evaluate a third times 10.5 squared times 18, and then tack on a pi after we find that digit. So 1/3 times 10.5 squared times 18 leaves you with 661.5. And so that's in terms of pi, but of course we have the other piece where if we actually multiply that number by pi, we're going to get 2078.2, and our units are centimeters cubed. All right. In number 6, they want you to find the volume of the cone given this image. So they give you the radius, which is 7, and the height of the cone, which is 25. So this is our R, this is our H, and we're just going to plug them into our formula. So our volume is 1/3 pi r squared height. So 1/3 times pi times the radius of 7 squared times the height of 25. Again, they want it in terms of pi and rounded to the nearest tenth. So if we evaluate this piece here, 1/3 times 7 squared times 25 gets you 408.3 repeating, and a pi included in that. And then to make it into its decimal equivalent, we could multiply that 408.3 repeating times pi, and we get 1,282.8. And our units are feet cubed. All right, the last example has you exploring the effects of changing dimensions. Oh, actually, it's second. Oh, no, last example. All right, and so remember that we did do a little bit of predicting before when we had 1 dimension and we were moving into 2 dimensions. We multiplied by 2. We squared whatever that multiplier was. But when we move from 1 dimension to 3 dimensions, we took whatever that multiplier was and cubed it. So looks like the length, width, and height of the rectangular pyramid are multiplied by 1/4. So potentially we're multiplying in this 1 dimension realm times 1/4. And so if you're multiplying by 1/4 in 1 dimension, then you're multiplying by 1/16 in 2 dimensions. And you're multiplying by 1/64 in 3 dimensions. So again, all I did was take the 1/4 and square it, so 16, and then cube it, and so that's the 64. So we can already describe the effect of the volume. The volume is going to be reduced by 1/64. And we can just say multiplied instead of reduced. And again, that came from 1/4 that we brought to the 3 power. All right. They do actually have an image here that you could go ahead and actually find the original volume and then the new volume. But it turns out that all it's asking is to describe the effect of the volume. And so we don't need to actually find it to be able to describe it. But of course, you could take the time to find the volume of this rectangular pyramid. And then you would see that if you divided it by 64, you'd get what happens if you make this 5 and what's 1/4 of 24, a 6, and then a 5. So if you made each of those 5, 5, and 6, you would get 1/64 of the original volume. All right, again, this is a very key concept here of how to switch from one dimension to the next.